The thermal loop also includes a system called a relay. The temperature controller sends a signal to the relay. There's really three main types of relays used to switch power to an electric heater. They act as a gate for the voltage to go to the heater so that it can create the heat. One type is what's called a mechanical relay. These are often called motor starters or just plain relays. They tend to be mechanical devices that switch on and off. Then there's a solid state relay, which switches on and off at a higher frequency and can last a lot longer, can have up to 1,000,000 cycles. And then finally, there's the SCR, a silicon controlled rectifier. SCRs are the finest type of relay that are given a signal from a temperature controller to control a load and are capable of making changes on-off multiple times in 1 second. Mechanical relays are a relay that make and break voltage to a heater. In other words, they get a signal from the controller and then the coil is pulled in and the mechanical relay makes contact and allows the voltage to flow through the heater and back to the circuit. So just like a valve, or just like a lot of times people compare electricity to water, it opens and closes that gate to allow voltage to come on and come off. These relays have been around for a long time and they work great for low accuracy, high volume type applications, but they do wear out. They're limited to about 100,000 cycles. The most common types of mechanical relays are what's called like a motor starter or a mercury displacement relay. These relays, again, have parts that wear and can wear out over time, and they're not quite as accurate, so they're mostly paired with an on-off controller. A great example of how a mechanical relay works with an on-off controller running it would be if you pulled up to a stop sign in your car and the speed limit was 50 miles an hour after the stop sign. When it was clear, you put your foot all the way to the floor, 100% power for your car, up to 50 miles an hour, and as soon as you hit 50 miles an hour, you take your foot all the way off the gas. You don't hit the brake, but you take your foot off the gas. And then when you go below 50 miles an hour, you put your foot all the way to the floor again. That's how a mechanical relay works in conjunction with an on-off controller. A solid-state relay is another way to switch power to an electric heater. Solid-state relays use diodes, which you could also call gates, and they can turn off and on as fast as 1 time per second. So it's a much finer form of control. So for a controller, you would need something like a proportional controller or a PID controller that's capable of sending signals that fast and listening to the sensor in the application and sending a demand to this relay. So these relays can turn off and on a lot faster. They provide a lot more accurate control and a much more dependable flow of electricity and use of electricity into an application. The temperature swings aren't as high when you use that type of a relay because they're being turned on and off every second at the minimum. An SCR power controller is another form of relay that you can use to transfer power after a signal is given to a relay to your heater in your process. An SCR power controller utilizes diodes that can turn off and on 120 times per second. Every single cycle crosses zero from AC to DC. There's 60 of those in 1 second. An SCR power controller is capable of turning off and on 120 times per second. So if you have a controller that's capable of sensing your process and asking for changes multiple times in 1 second, an SCR can handle the job because it can change the output to the heater rapidly and accurately. So if you need precise temperature control or a more efficient use of your electric power, an SCR power controller is a very easy upgrade in a system that needs to be accurate